Let's take this problem. Leave a space on the top just a little bit because I'm going to go higher. $100 8 ohm resistor, 4 ohm resistor, 2 ohm resistor, 3 ohm resistor. From the 3 now, that's 10 ohm, and 8 amp, five. And let's say you're going to do this by hand, no calculators. You're trying to decide which method is better. Should I do it with nodal analysis or should I do it with mesh analysis? Well, the way we decide is based on how many equations by how many unknowns you're going to have. Now, if I decide to go with nodal analysis, let's look at nodal right now. I need to know how many nodes do you have there that we don't know the voltage to. So for nodal here, I know the voltage. If this is ground here, if I make this my ground, I know what this node is. What's the voltage there? 100. What about this one? Do we know what the voltage here? No, that's V1. Do we know what the voltage here? No, that's V2. Do we know what the voltage here? No, that's V3. So you will have what? 3 equations by 3 unknowns. If I decide to go with nodal. If I go with mesh here,
you'll have 4.
well, we know one of them actually there. Look. For that one. This is 100. I'll redraw the circuit. 8, 4, 2, 3, 10, 5, and this is 8 amps. With mesh analysis, we draw currents, and you want to make them clockwise, counterclockwise, up to you. Now this one will be what? I sub 1. This one will be I sub 2. This one will be I sub 3. But that current now will be what? Instead of I sub 4, what's the value of that current?
8 amps.
That's negative 8. Notice because this current's going which way? It's going to the right on the top one. That's a negative 8. So if you know that's negative 8, bless you, that's also going to give you what? 3 equations by 3 unknowns. So in this example, it really doesn't matter. Now, since the actual equation, the math, it's really easier in mesh, I probably will choose mesh for this method versus nodal. So for this example, I will tend to go with mesh analysis. I find the math a little bit easier there. So if I was to do this, I'll stick with this method. Here we go, mesh 1, or loop 1. So minus to plus, that's a minus. Plus what? 8 I sub 1. Luke, is that you? Okay. Plus 4 times what? Now notice I'm going clockwise. I'm looking for the current down. And what's that current down?
I sub 1 minus I sub 2.
I sub 1 minus I sub 2. equals 0. And if I clean that, 8 and 4 is 12, minus 4i sub 2, there is no I sub 3, that's 0, equals 100. That's equation number 1. That's why I like the mesh. The actual math itself, it's easier. Now let's look at this one. We're going clockwise, so I need to know the current this way, the current this way, the current that way. I'm traveling clockwise. So loop 2. There is no source, so I'll start with that one. It's 2 times, what's the current through that, going that direction? I sub 2. Plus 3 times, what's the current down? I sub 2 minus I sub 3, yes. Plus 4, what is the current up? Two minus 1 equals 0. Clean it. I got negative 4 I sub 1. 2 and 3 is 5. 5 and 4, 9. 9 I sub 2 minus 3 I sub 3 equals to 0. Equation number 2. And loop 3, right here. Let me begin with the 5 here. This is the current going this way. This is going up there. This is going to the right. So it's going to be what? 5 times, what is the current coming down through the 5? I sub 3. Plus 3 times, what's the current up? I sub 3 minus I sub 2. Plus 10 times, what's the current to the right?
I sub 3 plus 8.
I sub 3 minus a negative 8, yes, which is plus 8, equals 0. Now let's clean it. There is no I sub 1, that's 0 I sub 1. I sub 2, do we have I sub 2? It looks like negative 3 I sub 2. 5 and 3, 8. 8 and 10, 18. I sub 3 equals what? Negative 80. And that's my third equation. Now I should be able to go to my calculator, type these values in, or if you want to use algebra to solve them, substitution, elimination method, whatever technique you want to use, determinant, Gauss-Jordan, anything. So 3 by 3. There we go. 12, negative 4, 0, 100. Negative 4, 9, negative 3, and is 0. The last one, 0, negative 3, 18, and negative 80. Solve. Right there. I sub 1 equals 9.26357 amps. I sub 2 is equal to 2.7907 amp. And I sub 3 is equal to negative 3.97933 amp. And if you're looking for anything else in that problem, then you can just solve for them. The question actually for this was find what is I sub 2 or I sub x, and they define I sub x as the current going through that. So that's the 2.79. Again, because of the calculator, it really didn't matter if I used mesh or nodal, but if you were doing them by hand, that's a little bit easier to deal with than nodal analysis, because the equations there get a little bit ugly, the math in them. So for this example, it didn't make a difference which method to use. Since the algebra is easier with mesh, I opted to go with mesh over nodal analysis. Sometimes a problem will give you actually 2 equations by 2 unknowns in nodal, but 3 equations by 3 unknowns in mesh. So in that case, you want to use the appropriate method. So let me see if I can find one that looks like that. Let's take this ugly problem. When I say ugly, just it looks big, not really, I don't know how difficult it is, but one, three amps, 2, 5, 7, 3, 4, 6, and the current source right here. Okay, and let's pick something to solve for. Let's say I want to solve for this current. Find I sub x. And again, I'm trying to decide which method for me will be better. Now let's look at nodal analysis. If I decide to go with nodal, how many equations by how many unknowns? So if this is my ground here, this is what? One node, V1. This is another node, which is what? V2. This is another node, which is what? V3. And the top will be what? V4. How many equations by how many unknowns? 4 equations by 4 unknowns. Now let's look at it in terms of mesh analysis.
What was the value of that current source on there?
This one, 2. So let's say I decide to go with mesh with this. This is 1. We don't know the value of it. That's I sub 1. This is another one. I sub 2. I sub 3. I sub 4. And this one will be what? The way I drew it, the current. Negative 2. So this is really, again, how many equations by how many unknowns? 4. So it didn't make a difference again which method to use here. Well, let me modify this problem. I don't like this problem. Let's say this source here, because I'm trying to show you sometimes one method is better than the other. Let's assume this source now is actually a voltage source instead of a current source. So different example. So this is either method. So the solution to that, which actually they're not even asking us to solve it. It says how many nodal equations would be required to solve for I sub x. And again, if you decide to go with mesh equations, how many mesh equations would be required? Would you prefer to use mesh analysis or nodal analysis? Since the number of unknowns is the same, me personally, I'm going to prefer to go with what? Mesh analysis. But let me modify the problem. So a different problem now. So in this case, we're either method.
Do we know what either I sub 1 or I sub 2 because there's 3 here?
Nope. All we know the difference between them is 3. I sub 2 minus I sub 1. So that's just an equation. But you don't know what the value. Either method. Personally, I will pick mesh. But if I change this to a voltage source, let's say 3 volts. Let's change that problem and show you what will happen. So a different example. I want you to think it's always the same thing. So hopefully people will listen to the video, because if they say, why did he change the current source to a voltage source? This is a different example. Maybe I should write on the top different example. Different example. Because they might think they're watching the solution to the first one. So let's look at nodal now. This is ground. If this is V1 here, what's this voltage here?
V1 minus 3 volts.
How about plus 3? V1 plus 3, because this end is 3 volts higher than that end. This is what? Do we know what the value there? No, that's V2. Do we know what the value here? V3. How many equations by how many unknowns? 3, right? That's your supernode. That'll be 3 equations by 3 unknowns. Now, if I try to attempt this with mesh analysis, that would be 4 by 4.
You could still use the mesh analysis, it'll just take longer than doing
Yep, it'll be 4 equations. I sub 1, I sub 2, I sub 3, I sub 4. The question Luke asked, can I still use mesh analysis? Absolutely, I can use it, except now what? 4 equations by 4 unknowns. So if you're taking a class where your teacher does not allow you to use calculators to solve, you got to do it by hand, you got to be out of your mind to solve 4 equations by 4 unknowns when the option is what? 3 by 3. Since I can use a graphing calculator to solve, I'm going to go with that method, even with the calculator, because that's 3 equations by 3 unknowns. So let me solve that. So this is I sub x. That's what we're looking for. Can we find what I sub x is? That was the question. Find I sub x. Bless you. So now we're going to start assigning current going up or down. It doesn't matter. You choose. It will not make a difference. So for the 1 ohm, which way? Up or down? Up? Okay, up. You want it to go up? That's I sub 1. For the 2 ohm,
Down.
I sub 2. For the 5 ohms,
Down.
down, I sub 5. 3 ohm,
Up.
for the 4 ohms, I'll go down just to be different, I sub 6. The 6 ohm, I'll make it going up just to be different.
Should that be I sub 4 and I sub 6?
I sub 4, yet I'm going by resistors, and that's I sub 6. Okay. Here's KCL. You'll see the math now. It's not as pretty with nodal when you compare it to mesh. KCL at supernode. What is going to that node? There's that supernode. The way we drew it, there's nothing going to it, right? 0, because it's the current going into that node should equal the current coming out of that node. The current going in equals the current coming out. There's nothing going into that node. What's coming out of it? I sub 1, I sub 2, I sub 3, I sub 5. Now again, look how I drew I sub 1. I sub 1 is going up. So it's this voltage minus that voltage. It's V1 minus V3 divided by 1. I sub 2, I drew it coming down. So it's V1 minus this end, which is 0, divided by 2. I define I sub 3 going up, so it's this voltage, which is V1 plus 3, minus
Oh, there's the plus 3.
V3, V1 plus 3, minus V3 divided by 3. And I sub 5, it's V1 plus 3, minus 0 divided by 5. And now I just got to clean it. That's why the math a little bit messy here.
I sub x is also leaving it in.
I sub x, I forgot I sub x, thank you. And I sub x is what? Plus V1 plus 3 minus V2 divided by 7. Yowza, yowza, yowza. What's the LCD? 770?
Yeah, 30, no.
Can you divide 70 by 3? I don't think we can.
I was thinking,
It's actually 210, I think. 210. So I got to multiply the entire equation by 210. So even if you have 3 equations by 3 unknowns, you can see the math is going to make it a nightmare. I'd rather do the 4, but we'll do them the way they want us to do them. So 210 times nothing is 0. 210, I'll go V1 minus V3 for now, plus 210 divided by 2, what's that, 105? Is that 70 the next one? 70 times V1 plus 3 minus V3. 210 divided by 5. Let me divide the 210 by 5. Clear.
40.
Is it? Yeah, 42. 42 times V1 plus 3. I think that's a 30, the last one. 30 times V1 plus 3 minus V2. All of that just to get the first equation. And let's see if we can clean it. Maybe I'll use a calculator here and go away. There we go. Clear. F3, F18. Okay. 210 plus 105 plus 70 for V1 plus 42 plus 30. 457 V1. For V2
It's just 30?
is negative 30. Is it negative 30 here?
Yeah.
For V3, I get negative 210, negative 70,
Minus 280.
280 V3 equals. That's 210 here. Let's see, 70 times 3 plus 42 times 3 plus 30 times 3. Is that negative 426 once you move it to the left side? I think 426. And that's equation number 1. So when the book says which one is really easier to deal with, they say easier in terms of how many equations by how many unknowns. But you can see the math for nodal is much worse than mesh analysis.
So you almost always do mesh?
Well, not always. There are some cases when you look, there's only 1 or 2 equations by 2 unknowns versus 4. And it's not really that bad. So now let's get 2 more equations. How about KCL of V2?
Isn't because that's a supernode, isn't it the same as V1?
V2. This one.
V2.
Oh, that's my V2, not this one.
Oh.
That one, yep. So let's do KCL of V2. Yeah, I can't do this one. That's the same as this. Right there. And again, if you take all the current going in, should equal all the current coming out. What's going in is this current, I sub x, I sub 4, and I sub 6. And what's leaving? Nothing. Again, I sub x is this one minus that, so it's V1 plus 3 minus V2 divided by 7. I sub 4 is coming down, so it's the top minus the bottom. It's V3 minus V2 over 4. And I sub 6 is the current going up, so it's this minus that. I think 84 is the LCD. I think it's 84. All of that equals 0. So let's multiply by 84. What's 84 divided by 7? 12. So I will have 12 times V1 plus 3 minus V2. 84 divided by 4, that's silly because that's 21. 21 times what? V3 minus V2. 84 divided by 6, is it 14? It's 14 times negative V2, and 84 times 0 is 0. Let's clean the math. I see 12V1. Any more do you see there? 12V1. V2, I got negative 12, negative 21, and negative 14. 12 and 21 is what? 33? Is that 47? 12 and 21 is 33 plus 14, 47, I think. And what do we have for V3? Is it just 21? Twelve times 3 is what, 36? Move it to that side, negative 36. That's equation 2. I need one more. Then I will have 3 equations by 3 unknowns. So where's my third equation going to come from?
That's the source on the right.
Which one?
That's the source on the right.
What are you going to do with the current source on the right? Look.
V3.
Yep. I have to do KCL and node V3. The top. Again, all the current going into the node should equal all the current coming out of that node. Going to it is I sub 1, I sub 3, the 2 amps going to it, and what's leaving? I sub 4. I sub 1 is what? V1 minus V3 divided by 1, because it's going up. It's this minus that divided by 1. I sub 3 is going up, so it's this voltage minus that. So it's V1 plus 3 minus V3 divided by 3. Plus the 2 equals I sub 4 is the top minus the bottom. The top is V3 minus V2 divided by 4. The good news here, my LCD is going to be small. It's going to be 12. So if you multiply everything by 12, I will have 12 times V1 minus V3 plus 4 times V1 plus 3 minus V3. 12 times 2, 24. 3 times V3 minus V2. Let's combine like terms. 12 and 4 is 16 V1. Let's look at V2. Nothing here, nothing here, there's that one. 3 times, that's a negative 3. Bring it to this side, plus 3. I got negative 12 here. Negative 4, that's negative 16. And negative 3, 16 and 3 is 19.
Don't you also have the negative? No, never mind.
Equals 4 times 3, 12 and 24 is what? 36, move it to the right side, negative 36. And there's my third equation. So now if I go to my calculator and I plug them in, I'm going to say I have 3 equations by 3 unknowns. Three by 3. The first one has 457, negative 30, negative 280, negative 426. That's the first equation. Second equation has 12, negative 47, 21. The answer is negative 36. The third equation has 16, 3, negative 19, negative 36. So I said solve. And here's my answers. V1 equals 0.074. V2 equals 1.785. And V3 equals 2.239. I forgot what the question was. I think it was a current. Let me look back and see. What was I sub x? It wasn't this one. It was this one. What was I sub x? It's this voltage minus that divided by 7. So I sub x is equal, this voltage is V1 plus 3 minus V2 divided by 7. Once I know V1, V2, and V3, I'm done. I know what V1, 0.074, add 3 to it, that's 3.074, minus V2, which is what? 1.785, divided by 7. So let's see, 3.074 minus 1.785, and take the answer and divide it by 7. I sub x is equal to 0.184 amps. Again, did really 3 equations by 3 unknowns made the math easier? Not really, because look at the algebra. Finding the LCD and multiplying, not a pretty way of doing it. But if you don't have a calculator, and again, if they're forcing you to do it the correct way, which one's easier? The answer to that depends only on how many equations by how many unknowns. That's how they decide which one's easier. Not how difficult the math, how easy the math. If you have 3 by 3 versus 4 by 4, they'll tell you go by 3 by 3. And again, in some of them, you could end up with 2 equations versus 4.
Is there any going to be ones where like we have less equations with mesh or no?
Yes, I can give you one. Less equation with mesh, you asking?
Yeah.
Okay. Well, with one over the other, you have less equation with mesh. You'll have less equation with mesh if you have a lot of current sources in the circuit.
How about for KCL, if we had fractions for resistors? We wouldn't have to do the fraction flipping or the LCD?
Well, in terms of the math, he's saying the math would be easier. The math with mesh is always easier, with mesh. You know, because you're not dividing by the resistor. It doesn't matter, you know? If it's a KCL?
Yeah.
Yep. I'm saying KCL, that's nodal analysis. So that the math is always more complicated. It's always going to be a fraction, and you got to clean it, find the LCD, and multiply.
Even if
But
the resistors are fractions?
well, even if it was 2/3, still going to multiply by 3/2. So you still get a fraction either way, you know. But for example, you asked me if it's easier if I do with mesh analysis. Is that what you asked me? Okay, I'll do one. Let's say we have a voltage source here, 96 volts. I'll put here 4 amps. This is 6 amps. Dependent source here. Plus to minus 0.1, we'll call it Vx. This is 40, and let's call this Vx right there. Let's put this is 20. Just don't like the way I wrote the 0.1 Vx because it's in the way now. This is my need an eraser. Wow, where's my wow? Oh, there we go. Squished in, so I gotta move it a little bit there. 0.1 Vx, was it? And let's say this is 10. And you asked me if there's a way mesh will be easier. Let's put a current source here. The value of 5. Let's say the question, find Vx. Now, if this is ground, I should have made this current source even be better. If I made this a, you know what? Let me make this current source. I want to show you definitely this is much better. Even with this, still better. Let's make it 9 amps. Like this. I want to just prove to you this is like, if you do now nodal analysis, nodal here, do we know what the voltage here is? No, that's V1. Do we know what the voltage here? That's V2. Do we know what the voltage here is, if this is ground? Vx. Do we know what the voltage here? Well, think again. Isn't it 1.1 Vx? Because this end is higher than that end by 0.1 Vx. So if this is Vx, this is 0.1 more than that, is 1.1. So how many unknowns do you see there? V1, Vx, and V2. So with nodal, this will be 3 equations by 3 unknowns. With mesh, let's do mesh analysis. Do we know what that current is? 9. Do we know what that current is?
-5.
-5. Do we know what this current is? 6. Do we know what this current is?
4.
How many unknowns do you have there?
0.
0. Yeah, I could have left one as a voltage source, still would be one unknown, right? But I want to be really obvious. So if I left this as a voltage source, which initially was a voltage source, that'll be what? One unknown? If I left this as a voltage, you know what the voltage is. So it'll be 2 equations by 2 unknowns versus 1 equation by 1 unknown. That's the difference. So sometimes one method is better than the other. So in this case, oh, then what's the current? I go, what's the voltage Vx? Well, what's the current down here? Because Vx is defined plus on the top minus. Vx is going to be 40 times the current down. Well, what's the current down? It's 9 minus this current up, which is what? -5. It's this one minus that one. That's 14. Done. Problem is done. But if I went to nodal analysis, I would have 3 equations by 3 unknowns, and I will get that eventually. Yes.
Isn't the 6 amp also coming down across VX?
Where's the 6 amps? Here?
Yeah.
It's going to split, you know?
Okay.
So actually 6 going in, 5 coming in, that means 11 coming out this way. KCL, you know? Now, I didn't think about the problem to see if this is really possible or not. I'm putting all these sources. You know, I didn't plan it like correctly to see some of the current, does it equal to that? Because right now we have 11 here. So I got to look at the math. I just did a quick example there just to show you what will happen. But if I did nodal analysis, that's 3 equations by 3 unknowns. Mesh says I don't need any. I'm done. With mesh, 0 equations. Because you know every single current. I just go to Ohm's law. I say, oh, they want plus to minus 40 times the current. And that'll be my solution, that line. 2 steps. I want to go to the extreme of this, really. Again, I couldn't tell you if this is possible, this circuit, but something with sources like these, I mean, the values will be different, could be. I just drew something up just to show you where the math says if you do nodal, that's 3 equations by 3 unknowns. But if you do mesh, you don't even have any unknowns. You can just go directly to Ohm's law, and there's your answer.
So basically, if you see a lot of current sources.
A lot of current sources, that's an indication. Yep, you know a lot of the unknowns. If you see a lot of voltage sources in the circuit, that's an indication nodal is better, because when you have a lot of like if I change these 2 voltages right now instead of current sources, I will have 1 equation by 1 unknown. Where if I did mesh analysis, it will be 2 equations by 2 unknowns. Watch this. If I change this to, I had 96 before, right? 96 volt. So if I change that to this circuit, and I'll put some numbers in it, that's 6 amp, that's 10 ohm, that's 40 Vx, yep. I need a value for that source. We'll call that, I don't know, 5 volts. It was 5 amps, let's call it 5 volts. Now in this case, I know the voltage here. What's the voltage here?
96.
96. What's the voltage here? 5 volts. What's the voltage here? Vx. What's the voltage here? 1.1 Vx. How many unknowns? 1, just Vx. So with nodal here, 1 equation by 1 unknown. That's your supernode. Now, if I do KCL, mesh analysis, I know this current, that's what? 6. I know this current, that's what? 4. What's this current and what's that current? Unknowns, right? So you'll have how many equations by how many unknowns? 2 equations by 2 unknowns. So when you have a lot of voltage sources there, I say, hey, nodal might be a better choice. When you have a lot of current sources, I say, hey, maybe KCL might be a better choice, or mesh analysis. Keep saying KCL. So if I want to solve this, in this case, I will do with nodal analysis, I go, okay, let's assign current going to that node. What do you want through the 20 ohm? Going in, out, which way?
In.
And like down?
Yeah.
This one, down or up?
Down.
And the 40, up or down?
Down.
Down. So if you do KCL of the super node, what do we have? What's the current going in? We got the 4 amps going in. We got I-20 going in. We got I-10 going in. And what's leaving that node? I see the 6 amp leaving up there, and I see I sub 40 leaving down there. That's it. Now I gotta write these in terms of Vx. I-20, that'll be what? 96 minus Vx over 20. I sub 10 will be what? It's coming down, so it's that voltage minus this one. I sub 40 is coming down, Vx minus the ground over 40. What's my LCD here? 40. What's 40 times 4? Is it 160? Plus 2 times 96 minus Vx plus 4 times 5 minus Vx equals, is that 240 plus Vx? Let's collect all the Vx's out. That's negative 2 Vx minus 4 Vx, that's negative 6, negative 7 Vx. 240, let's see what that number was. 160 plus 2 times 96 plus 4 times 5 that'll be negative 132 when you move it to that side. So what's Vx equal to? 132 divided by 7, 18.86. So notice in this example, mesh analysis was really the better choice. I mean nodal analysis, sorry. I use nodal for this. One equation by one unknown. The previous one, the same example, I just put a lot of current sources there. Mesh was the choice. A better choice. Okay, that's the end of this one.